Hello, young ladies. I want to help you out with problem 7, which I think is difficult. Um, it's really a two-part problem because the first thing you have to find out is how fast will the marble be when it rolls down this ramp? Let me just back up. Here's the scenario. You place the marble at the top of the ramp, the same ramp that was used in this lab, and you place it 1 meter up the ramp. So you know what that means? That when it comes to the bottom of the ramp, it will have traveled 1 meter. Your marble were released at that point, that implies that if it's placed at the top of the ramp, in the very beginning, VI equals 0, and it rolls down that ramp. At the bottom of the ramp, it'll have the velocity. At the bottom of the ramp, it'll roll down to the bottom of the ramp and then launch horizontally off the table. So if we are to find out, what you ask here is, once it rolls off the table, how far from the base will it land? That's actually dx. So that's part 2. This is a two-part problem. First part is how fast will it be when it reaches the bottom of the ramp. If it's put on the bottom of the ramp, VI equals 0, it rolls down a ramp that's 1 meter long. That same ramp used in the lab, how fast will it be at the bottom? That's VF equals question mark. Now, the fact of the matter is, you take your acceleration, which I think most of you got, 1.4 meters per second squared? Take a look what we have. We're going to place the marble at the top of a 1 meter ramp. We'll let it go, VI equals 0. It'll accelerate with whatever acceleration you have, 1.4, 1.44, or whatever. Look what we have, D, we have VI, we want VF. Why do we want VF? Because we want to know how fast the marble is when it rolls off the table. So look, I'm not going to tell you, but if you've got 4 letters, you know the equation. Well, I think I will. No. Take a look at these 4 variables. In order to find the velocity at the bottom of the ramp, you have to find a motion equation that has VF, VI, A, and D. And once you find that, you'll be able to solve for VF. Now, you're not done. You just have the velocity at the bottom of the ramp. Now, once it hits the bottom of the ramp, it rolls horizontally off the table. Whatever velocity you get becomes your Vx. This will be your answer. Your answer, whatever answer you get, you'll put in here. Now, once you do that, you've got a second part to the problem because we want to find dx. Well, if it rolls off the table horizontally, maybe I'll start you. VIY equals 0. I hope you know that what AY equals. dy is, well, let's see, it's given over here. Right there, the height of the table is. So that's my little help on that one. I can't give you everything, but you have the height of the table, you have the dy, you have the AY. You know VIY equals 0 because it rolled horizontally off the table. How are you going to get the D? Well, that's where how are you going to get the dx? I'm going to leave you to solve that problem. So once again, it's a two-part problem. You place a marble 1 meter up a ramp, the same ramp that was used in this lab at the same angle. So you're going to use your acceleration. If your acceleration is not 1.4, don't use 1.4. Use your actual acceleration. So if a marble was placed at the top of the ramp, 1 meter up the ramp, VI equals 0, you have to find the VF. And whatever you find as your VF, whatever this becomes the horizontal velocity as it rolls off the table. You bring that answer down here, and you solve for dx. And I can't give you that one, too. You're going to have to work on that one. I'm going to post I'm going to post a little something on Google Classroom for some help. And look, here, we got it all out of whack. And so there you go.